Hello students. Now today we will continue with our last session, right? So in last session we have discussed about the routing protocol features, right? Then we have also discussed when we are going to do the static routing, when we are going to do the dynamic routing, right? And what are the different features of interior and exterior routing protocols. Under that, what are the different examples over there for the routing protocols. Also we have discussed distance vector, link state, and the hybrid protocols are there. And for selecting the best path for routing the packets, right? How you are going to distinguishes in between the different protocol metrics, right? And with the help of that, how you are going to select a best path, right? So that also we have discussed. For example, hop count, we will see bandwidth, delay, then the reliability of that particular link and the load on that particular link, right? All these are the metrics we are used to select the best path, right? Then the routing protocol convergence, right? That also we have discussed. The flat hierarchical routing protocols, right? What are the examples of these protocols over there? And the different comparison of these particular protocols in order to see the different features, right? And so accordingly the different features, what are the different protocols are compatible with, right? That also we have seen. And also how this particular protocol selection will be there with respect to the decisions if you wanted to take, right? That also we have discussed, right? So in today's session we will start with this first, the administrative distance means what, right? How it going to be help us in our designing topology. Then how to select the best route to transfer the packet from one network to another network, right? Then some the concepts of the route filtering means what do you mean by the route redistribution is there, and the route summarization part, right? So all these things we will see, because all these things may be asked in your examination as a short note on route filtering, route distribution, and the route summarization, right, for 10 marks. And all these things we will be very much important with respect to your examination also, right? So we will start with this, right? So we have covered this with the last session. I will just move directly go to that particular. Yes. So before that we already in last session studied about this particular EIGRP, OSPF, and all that things, right? But if for in project Vivas, mini project Viva, or in your examination also, if you ask when you are going to choose the EIGRP routing protocol, right? So you must know what are the different features of this particular EIGRP protocol, right? And when you are going to be used, in which scenario you are going to be used this particular EIGRP protocol, right? So that you must know, right? So that's why we will cover this today, right? So when you are going to choose this particular EIGRP, right? So you already know this particular EIGRP is nothing but your Cisco proprietary hybrid protocol, right? Which will be incorporates the best aspect of your distance vector as well as your link state features, right? So that's why we can call this EIGRP is nothing but your hierarchical routing protocol, and it is a vendor specific because it is having a Cisco proprietary hybrid protocol will be there, right? So it will be maintain 3 tables also, the routing tables by default, then topology tables, then the neighbor tables, right? So it does not perform any periodic route updates over there. It does it performs the triggered updates, right? So whenever you wanted to get the updates, you can get it, right? Then it will be suited for almost all environments, right? Including if you see the LAN, if you see the point to point, or if you see the other kind of things, right? So in order to all environments, this particular EIGRP will be the best suited, right? So this will be not suited for your dial-up environment, right? So EIGRP will not be suited for your dial-up connection over there, right? So because if you see, it must be maintain its neighbor relationship using some periodic hello packet. So you already know this EIGRP you are going to use with some hello protocols to send periodic updates, right? So in that dial-up connection you are not getting all these things, right? Because sending these packets would mean that the dial-up connection would have to stay stay up all the time, right? So all the time that dial-up connection will be stay on. That will be not possible, and that's why this particular EIGRP will not be used in that particular dial-up connection. So after that it will be used in the various environment, right? So I discussed LAN, point to point, and all that things, right? So in that way you need to choose whenever any organization demands, if we are having any Cisco based environment over there, right? And if all these possibilities over there, then and then only you can be choose this particular EIGRP, right? So that is enhanced interior gateway routing protocol, Cisco proprietary or vendor specific protocol, right? Then when to choose this particular OSPF, open shortest path first protocol, when you are going to choose, right? So obviously you already know this OSPF is also a link state routing protocol over there, right? It will be used shortest path first algorithm for calculating the base path, right? It will be uses Dishkeshra's algorithm to finding out the base path, right? And if designing this particular network with respect to OSPF, you can be used of the point to point links, right? And later you can use it in a LAN environment as well, right? And this can be also used in a dial-up connection with OSPF on demand circuit features, right? And it will be also support your hello protocol to make a connection with this particular thing, right? This OSPF also we can be used in a hierarchical area requirements, right? Where you can be design constraints in the larger network, right? And where the area will be required, in that case this particular OSPF can be used, right? So this OSPF is also having some these kind of the features, right? And wherever there is an kind of the requirement with respect to areas and all that things, right? Or hierarchical network area requirements will be there, right? So in that case, in that scenario, this particular OSPF you can be used, right? So these are some features over there which you can be used as a part of this particular OSPF is concerned, right? Then we will see this particular routing in a campus core designing, right? So obviously in each and every part, if IP addressing plan, if you see, if this particular routing, if you see in public and private addresses, if you see, right? So we are always compared with our enterprise area network, right? So in which different functional areas will be there, and according to that functional areas, this particular this particular technology where it will be well suited, right? So that we are going to identify over here, right? So if you see in this particular enterprise network, enterprise campus network, right, for building access, distribution, and the core layer, which will be nothing but the hierarchical design, right? So over there you can be use this particular EIGRP, or you can be use this particular OSPF part as well, right? And if you concern with your the enterprise edge designing, that, so that is nothing but your we can be called it as your enterprise edge in e-commerce, ISPs, and all that things, right? So over there you can use if you're using ISPs, right? So obviously there is a concept BGP will be there. So we already discussed about the BGP, that is nothing but the border gateway protocol, which will be able to connect in between the autonomous systems, right? So in ISPs, that may be a condition, that may be a case in that you are going to use this particular BGP, okay? Or if you are using some public kind of servers and all that things, right? So in that case, in the core part, you can be used the static routing also, right? So in that way, in that case, the static routing will be helps to manually add the routing table, routing information in that particular router's routing table, right? So that can be done, right? This WAN or MAN or VPN side to side, in that this particular EIGRP or this OSPF both can be a part, right? So that can be a part over there. Then this particular enterprise branch, right? So here also you can be use any protocol in the EIGRP or OSPF, right? in enterprise data center also you can be use EIGRP, OSPF. If you see why this EIGRP and OSPF is everywhere, right? So you know that now these protocols are nothing but the dynamic routing protocols, right? So no need to manual upgradation over here, right? So all the things will be taken care of that particular protocols, right? Also it will be using a shortest path for that particular routing, right? It will be calculated automatically. It will be based on the routing metrics as well as, right? So all the features they are having, right? And because of that, this enterprise branch, enterprise data center, then particular that VPN, site to site VPN, and then this enterprise campus, we are going to use this particular EIGRP or OSPF mainly, right? So these are with respect to your enterprise design areas, right? Then we will see this particular route distribution part, right? So in this route distribution, if you see, I have listed here I have given here one diagram, that is redistribution occurs in the boundaries in between the protocol or the domains, right? So here if you see, the domains is nothing but the autonomous system over here, right? So for example, this is nothing but your the first autonomous system, this is nothing but your second autonomous system, right? And in between these two autonomous system we have one router over here, right? So this is nothing but the router of your BGP, right? What we have discussed in our BGP, right? So border gateway protocol. So this is nothing but your the border gateway routers over here, right? And because of that, the redistribution of the traffic will be transferred from one domain to another domain, that is from one autonomous system to another autonomous system, right? And this is the concept with respect to BGP you need to be studied, right? So route distribution will be done in that way, right? So so this is the concept of route redistribution, right? Then we will come to the our topic, that is administrative distance, right? So most of the protocol, if you see, which having some metric structure and algorithms, right, that will be incompatible with other protocols also, right? So it will be very critical in that case that a network using multiple routing protocols and will be able to seamlessly exchange route information and able to select the best path across the multiple protocols, right? So these Cisco routers which we are going to use that use a value for that administrative distance to select the best path, right? So when they learn of two or more routes to the same destination from different routing protocols, right? So this particular administrative distance rates that particular routing protocol's believability, right? That means it will be measure their probability over there, right? So with the help of this particular administrative distance, right, and it will be helps to that particular network to calculate the best path depending upon that particular value of that particular administrative distance, right? So the Cisco has assigned a default administrative distance value for each and every routing protocol that will be supported on its router, right? So each routing protocol is prioritized in order to from the most to the least believable, right? So if you see, for the root sources and the default distances for that particular administrative distance of routing protocols, right? So this particular external BGP is have 20 default distance, this internal EIGRP have 9 default distance, that is administrative distance, right? Then IGRP is having the 100 one. Then if you see in the what are the dynamic routing protocols we have studied, right? So OSPF having default administrative distance as 110, integrated ISIS is having 115, then RIP V1 V2 is having 120 is default administrative distance. So this administrative distance will be used by which to select the so the best path over there, to calculating the best path over there, right? So maybe the question can be arises in your examination also on this particular administrative distance, right? So when or why this particular administrative distance can be used, or what is the default administrative distance for OSPF, what is the default administrative distance for your RIP, and all these things questions can be asked, right? So that is also a useful part. Then selecting the best route. So obviously these are the two measures over there by which you are going to select the best route, right? So first of all, the administrative distance. So just we have studied this administrative distance, which will be used to rate a routing protocol's believability, right? So the probability it will be checked, or the believability it will be checked, and depending upon that it will be used to calculate the best path, and accordingly it will be transferred that particular traffic from one network to another network, right? So so that is one criteria to select the best route, right, by using some administrative distance part, right? Then the second one is your routing metric. So we have already that particular different routing metrics we have studied, right? So for example, the hop count we have studied, we have then some bandwidth, delay, then reliability, and the load of that particular link, right? So all these are nothing but your routing metrics over there, right? So this is nothing but a value which representing the path in between that particular local router to your destination router, right? And according to that routing protocol, whichever you are going to be used, right, this metric will be used to determine routing protocol's best path for that particular destination, right? So in this way this particular two by using this particular two techniques we will be select the best route over there with the help of some routing protocols over there, right? So this is also the important one, okay, that you need to study. And then route redistribution direction, okay, it can be way or the two-way, right? So if you see here, it is a single way from enterprise edge protocol to campus core protocol, or it can be a two-way redistribution over there from the campus core to enterprise edge protocol, or from the enterprise edge protocol to a campus core, right? So in a one-way route redistribution, if you see from this enterprise edge to this campus core protocol, right? So this routing information which will be redistributed from one routing protocol or one domain to another domain, right? But not vice versa. That means it will be not from this campus core to enterprise edge, right? So it is only from one way, that is from your enterprise edge protocol to your campus core protocol will be there, right? Or this static or any kind of the default route will be required in the opposite direction to provide the connectivity over there, right? So we already seen this particular thing in our static routing demonstration also, right? So we are going to provide a static or default route in between the two routers in order to send a traffic from one part to another part, right? So that is nothing but your one-way route redistribution in that particular topology, right? Whatever we have discussed in that particular experiment or the demonstration of the static routing part, right? So that is nothing but one-way route distribution, right? And now this particular two-way distribution, that is nothing but for the routing information which we wanted to redistributed from one routing protocol or one domain to the another domain, right? And vice versa is also possible. That means it is a both way, full duplex connection will be there, right? So static or default routes are not required in that case, right? Because all routing information will be passed between these particular two entities, right? Therefore no that particular default route we are going to use, no static route we are going to use in that particular part, right? So there will be a two possible ways over here for redistribution if you concern, right? So one way is also there, and the two-way redistribution is also over there, right? So that you need to keep in mind with respect to your route redistribution part is concerned, right? Then we have a route filtering topics with respect to that. So we will see one second. Yes, so in a route filtering, right? So if you filtering can be configured with the three part, right? So if you see, the route filtering will be required whenever the we wanted to redistributing the routes, right? So route filtering can be prevents the we can call it as an whatever the advertisement or acceptance of that particular routes through the that routing domains, right? So for preventing all this kind of the advertisement, this route filtering will be required, right? And how it can be configured. So on a routing domain boundary, right, where redistribution occurs, right? So there you can be configured route filtering. Then within the routing domain, to isolate the some parts of the network from the other parts, in that also case you can use this particular route filtering, right? And the third one, to limit routing traffic from untrusted external domains, right? From, for example, if you not wanted to communication with respect to your untrusted external domains, right? So at that time also you can be do this particular route filtering part, okay? So and at the time of if you wanted to redistribution on that particular domain boundary, right? So in that case also you can do this particular route filtering, right? Because see, this filtering will be used with the route redistribution, right? So it will be primarily it will be prevent the suboptimal routing, right? And routing loops, right? So which will be, we can call it as a multiple redistribution points, so right. So it will be used in the prevent rules about certain networks, such as it can be prevent from some private IP address space, right? So from being sent or from receiving from any kind of the remote sites and all that things, right? So that can be it can be used in a with the help of some route filtering over there, right? So in examination maybe asked, so what do you mean by the route filtering and its functionality, or how it can be configured, right? So it can be configured by the three ways, right? And when it can be done, so it will be required for your redistribution to your routes, or if you wanted to prevent any advertisement or acceptance of any certain routes, right? So in that case this particular route filtering can be used, right? So that you need to see, right? And then redistribution and filtering with the BGP, right? So BGP, that is nothing border gateway protocol, right? So we know that this particular BGP can be work in your autonomous system. There is an communication in between autonomous system to your different autonomous systems, right? So at that time this BGP will be announces only when major networks to the external domains, right? And it can be excluded any details about the subnet, right? So it will be not giving any network subnet information to external domains over there, right? It can be only communicated with autonomous system to autonomous system, right? So this is done in the BGP network when the router configuration command, which allows BGP to advertise a network that is already part of its IP routing table, right? Or whatever the internal network you need to summarize into one major net subnet, right? So that will be cover assign the public address space that will be redistributed into your BGP, right? So when it will be you are going to use this particular redistribution part whenever you wanted to do some internal networks summarization, right, into the major subnet, right? And the public address space if you wanted to use for that part, and the redistribution that will be done in that particular BGP part, right? So that you need to keep in mind. And also if you see the redistribution of all BGP routes into IGP, it will not be advised, because if you see non-BGP participating routers which do not require the full internet routing tables or IGP protocols, which were unable to process large number of advertised routes, right? So that's why this particular route filtering can be used in that case, right? So there will be no redistribution and part in that particular cases, right? Then we have this particular route summarization, right, and it benefits. So we will see the what you mean by the route summarization, right? So route summarization, which we can also call it as in route aggregation, right, or we can also call it as an supernetting, right. So subnetting we already know, right. So opposite of subnetting is nothing but the supernetting, right. That will nothing but the summarization, or we can call it as an route aggregation part, right. And by doing that, doing that we can be helpful to customize, or we can call it as optimized our route part, right. So in this single summary address in the routing table which will be given, and that is a representation of a set of the routes which are there in that particular routing table, right. So this summarization, what are the different advantages of this particular summarization part, if you see, right. So it will be reduces the routing update traffic over there. It will be whatever the number of routes in that particular routing table over there, right. So it will be overall router overhead will be larger in that case, right. So if you wanted to reduce, or if you wanted to decrease the overhead of a router, right, so you can be use this particular route summarization technique over there by doing some route aggregation, or by using some supernetting over there, and it will be just some representation, what we can call one summary of address, if it will be there, right. So in that case also you can be use this particular part, right. And if you see the benefits for this particular route summarization, right, so what can be advantages of this particular route summarization, if you concern, right. So large any kind of the large network, which if you see, right, so it will be not scalable, right, because whenever the routing traffic, whichever you're going to transfer from one router to another router, or one network to another network, right, so it will be consumes a very large amount of the network resources, right. And whenever there will be any change in that particular network, right, so the for propagation of that particular change in that particular all the network, it will be required very much processing time for that particular route recomputation and the bandwidth, right, to propagate all the routing updates over there, right. So if you wanted to do any kind of the change, any kind of the scalability, any kind of the load balancing in advanced or in addition to existing route, right, or in addition to existing network, right, then if you change a single thing in that particular network, then whatever the components, whatever the internetworking devices, whatever the routes, whatever the networks which will be depending upon that particular change, right, you need to propagate all these things in a whole network over there, right. And obviously it will be required much processing time over there for the route recomputation part, right. Again you need to calculate the route for calculating the base path, right. So obviously it will be consumes some of the bandwidths also, right. And because you need to propagate all the routing updates, right, and that's why the bandwidth it will be consumed, right. So this network hierarchy which we are going to use, right, it can be reduced this particular both routing traffic as well as this unnecessarily route recomputation part, right. So whichever I have told you just now, that recomputation you need to use, that bandwidth is also used large, right. But if you use this network hierarchy now, right, so it will be reduce the routing traffic because you are doing some network traffic also, and you are whatever the route recomputation you are doing unnecessarily, right. So that will also be reduced if you are using a network hierarchy over there, right. Because to do that this network must be divided into different areas, right. And that areas which we are dividing, that must be enable this particular route summarization part, right. And with this particular route summarization which will be occurs in one network area, which does not influence the routing in the other area. That means the different area is having a different kind of the summarization at their own places, right, which will be not hamper to other areas which we are used in this particular if you see in a BGP, or if you see in OSPF also, right. So it can't be affect a different network areas, right. so it will be reducing the amount of routing traffic over there because of that. And whenever the size of the routing tables, if you concern, right, so if you think upon the memory and the processing power of the routing, right, then it will be very much less as compared to first scenario, right. So if the summarization is configured manually, or it can be occurs automatically at the major network boundary, and by using some of the routing protocols over there, right, and it will be very important with respect to this particular network topology, if you concern, right. So this is the part of this particular route summarization, and we also discuss its benefits, right. So so we have in this particular topic discussed today about the different the administrative distance, right. So what do you mean by the administrative distance? What are the different routing protocols of administrative with respect to the administrative distance, right. So each and every routing protocols administrative distance we have demonstrated to you in on a table, right. Then how you are going to select a base route, right. What are the different criteria for selecting base route, right. So you can be use this particular administrative distance as one of the parameter or one of the way to select the base route, right. And another one is your routing metrics you whatever you are going to use, right. For example, we have seen the hop count is one of the routing metrics for your RIP, right. Then the bandwidth is one of the metrics for your EIGRP, or load, delay, then reliability. All are these are the some of the metrics, right, of your routing protocol. And depending upon these ways, you can be select your base route over there, right. So that is also we have seen. Then route filtering, we have discussed why you will require route filtering and which circumstances it will be beneficial for your organization. Then route distribution and the route summarization, right. So these all these techniques we have seen, these methodologies we have seen, right. So this is all about this particular today's session, right. So what we have covered in this particular chapter, if you see, right, so for the chapter summary if you see, right, so we have discussed first of all the IP addressing plan in your network, right. How this particular IP addressing can be done in your in any kind of the network design, right. So first of all you need to know this what do you mean by the public IPs, private IPs, right. How you are going to transfer, or how you are going to convert the private IPs to public IP, right, by using some network address translation. We have seen, we have discussed port address translation, that is PAT, right. Then we have discussed the IPv6. There are all address format, then header format, then there are some other fields over there, then the features of IPv6, then the comparison of IPv4 and the IPv6, right. All these things we have discussed. Also the transition strategies of IPv6, right. So that tunneling and all that part we have also discussed, right, in the IP addressing plan, right. And then we have moved towards this particular routing protocols part, right. What do you mean by the routing, right, how the routing can be done, what are the types of the routing, right, static routing, dynamic routing, then what are the different features of all these routings, then what are the interior exterior routing, distance, link state, hybrid routing protocols over there, what are the different routing protocol metrics over there, right. Then flat versus hierarchical routing protocols over there, right. And how what are the different comparison in between with respect to the features and all that things also we have discussed, right. So all these things will be very much important with respect to your mini project. Mini project is also concerned, right. So you need to go through all the videos of this particular lectures, right. Also you need to go through the NDL experiments with respect to this module is concerned, right. So experiment number 6, 7 and 5 with respect to this particular chapter is concerned, right? Because in that experiment number 5, the configuration of dynamic routing protocol, I have demonstrated, right? So that RIP is there, then next experiment is your about your EIGRP is there, and the next experiment is your OSPF is there, right? So all these protocols, how you are going to configure with respect to in that particular Cisco packet tracer, right? So that are also explained in that, okay? How with the help of some CLIs, with the help of some GUI, how to demonstrate, how to check, right? So all these things are already there, right? Although video links already I have shared with you all, right? So just go through all this implementation part, so it will be very much helpful for you to better understanding part of this routing protocols, right? Why I am giving much stress on this particular chapter, right? Because this chapter is very much important with your basic knowledge of your networking part, right? It will be helpful for your mini project as well, right? And as a point of view with your theory examination or your online examinations also, this chapter is very much important one, right? So that's why I'm giving stress on this particular model 5 more, right? So that's it for this particular chapter. Okay, we have ended up with your chapter number 5 over here. Now from the next session we will start our chapter number 6, right? So let's stop today. So we will stop today early, right? So we have ended up with your chapter. Okay, so thank you for joining.